Welcome to Algebra 2. This video is for Unit 5, Problem Set 1. Let's start. So, for question 1, you're trying to figure out if this function is exponential or not. Basically, exponential, if a function like this is exponential, that means the ratio of any two consecutive terms is always the same. That means 12 divided by 4 should always be the same as 36 divided by 12 and 108 divided by 36, which is true. It is just 3. The ratio is 3 and it's exponential. Now, question number 2. On October 12th, a fast-growing species of algae was accidentally introduced into a pond in a park. The area of the pond that algae covers doubles each day. If not controlled, the algae will cover the entire surface of the pond, depriving the fish in the pond of oxygen. At the rate it is growing, this will happen on October 24th. On which day is the pond halfway covered? Well, with this information, October 24th, it's saying that on October 24th, 100% of the pond will be covered with algae. Now, it doubles each day. That means the day before will be half of 100%, which is 50%, which is halfway covered. So on October 23rd, 50% of the pond will be covered with algae. On October 18th, Claire visited the park. A park caretaker mentions to her that the pond will be completely covered in less than a week. Claire takes a look at how much the pond is currently covered and thinks the caretaker must be mistaken. Why she might find the caretaker's claim hard to believe? Well, let's do the math. So starting at on October 24th, you have 100% of the things covered. It's decreasing by 1/2 each day you go back. So it's 0.5 to the power of d, where d represents per day. Now, how many days is October 18th away from 24th? Well, 6 days, right? So you see, 23 is 1, 22 is, whatever. So it's 6 days difference. So you plug in 6 for d, and you get 100 times 0.5 to the power of 6. Whatever is that is going to be very, very low number, like less than 2% or something. Now imagine this: if less than 2% is just this. They are saying this only this type is covered with algae, and you're saying in 5 days it's going to be the entire thing covered. It's harder to believe. The key thing is this: exponential grows really fast, right? So even though it's less than 2% 6 days ago, because it's growing exponentially, it's gonna go up really fast. You must have seen those videos on Instagram where you're asking you this: if someone gives you 1 penny that doubles every day, or $10 million. So 1 penny that doubles every day for a year, or $10 million. You always pick 1 penny that doubles every year, because over time that number is going to go exponentially higher, and that's why they're saying that. $10 million will be nothing in front of whatever you will be making with that. Now, moving on. What fraction of the area of the pond was covered by algae initially? So, how far is October 24th from October 12th? It's 12 days away. So you plug in 12 for D into your calculator and see what you get. Next page. Let's go there. Question 3. A home is purchased for $170,000. Since then, it has increased its value 5% per year. If it's increased at 5% per year, the growth is like 0.05. And since it's increasing, we'll use this formula: 170,000 times 1 plus 0.05 to the power of y. Now, 170,000 times 1.05. Here your y is 3 years afterwards, so it's 3. Whatever that is your answer. So, and we already have the equation. That's the equation right there. Will the value of the home be more than 500,000 in 30 years after it was purchased? So simply plug in 30. If it is greater, then you just say yes, it's greater. If it's not greater, you say it's not greater. Simply plug in 30. The graph shows the wolf population has been growing exponentially. What was the population when it was first measured? As I can see, we'll say 100, if it's between 80 and 120. By what factor did the population grow? Well, I see the next one is at 1, which is 120. So whatever is 120 over 100, which is what is that? 6 over 5, whatever that is. So 6/5, 6 over 5, and 1.2, I'm guessing. Now write an equation relating the roof population W. So initial population 100, growth factor 1.2 to the power of y, years, right? You can check it as well. Plug in 0, you will get 100. Plug in 1, you will get 120, and so on. You can check it as well to see if it's right. Alrighty, question 5. A chemical accidentally spilled into a lake and needs to be cleaned up. The cleaning process decreases the amount of the chemical in the lake roughly exponentially. Here is the graph representing f, an exponential function that models the amount of chemical left in the lake hours after the cleaning begins. Same thing here. Figure out actually use the graph to estimate f of 1 over 2. 1 over 2 is right there, and I think it's 3. It just says this. So you have 12 liters when you start beginning, and after 30 minutes it's 3 liters in there. So how do we figure out the rate of change? Well, always pick the one that's with 1 and 0, because that's the consecutive term. So you would do 0.75 over 12, or whatever that is. So let's just say that you're starting at 12. We'll do 0.75 over 12 to the power of h. That's an equation that defines the f. To study erosion, a laboratory sets up a model for a river so that half of the sand in the model is washed away every week. So half is washed away every week. So 0.5, you're losing 0.50% every week, 0.5. The model has 50 kilograms of the sand to begin with, so we'll do 50 times 0.5 to the power of w. Plug in 1 to see what your answer is, plug in 2 and plug in 3, and you will know the answer. And that's the now they want you to model this in terms of days, right? So how many days are in a week? 7. So you'll do 50 times 0.5 to the power of d over 7. Now see, on the 7th day it will be 1 week, and that's when the 1/2 happens. That's what they're saying. Explain what 4 divided by 7 means. Basically 4th day after, like, whatever they're measuring. What are they measuring? Like washing away. So like after the 4th day, what is the measure of that? That is inside the sand, the weight of the sand. The weight of the sand. Cool. Question 7. Let the function p represents the population model PD, population PD in thousands of a colony of insects d days afterwards. So d days, so here it is. This is in terms of days. Now, so each day you're having, whatever that is. There were 1060 insects. When there was, no, that's not true. There were only 10 insects, because that's what this is saying. 10 insects. 1 week after the colony was first counted, there were 10,600. Now, you would think to plug in 1, but no, it says 1 week. So you plug in 7, right? You plug in 7 because it's 7 days, and see what the answer is. If it's 10,600, it's the answer. If it's not the answer. The growth factor per day is 1.06, which is true. The growth factor is 1.06. That's what this is. The growth factor per week is 1.06 times 7. That's not true. It's 1.06 to the power of 7, not times 7. The growth factor per hour is 1.06, 1 over 24. That is true. If I were to convert this days to hours, I would do 1.06 times to the power of 1 over 24. The growth rate per day is 1.06. No, that's growth factor, not rate. Growth rate is 6%. That is true. Cool. Scientists measure a population to find bacteria population to find that it is 4,000. That's our initial. It takes 10 days to double, so it's 2 days over 10. So every 10 days it doubles. Yep, Same thing here, 4000, but now instead of doubling it halves, so it's 0.5 d over 10 days later. That's it. Basically whatever is below, however long it takes for it to do it for the first time, that's what it is. That's pretty much all. Let's stay on the video. Cool.